Hello everybody, we're going to pick up where we left off last week, and we were going through the first PowerPoint that's in the Unit 2 folder, or is it the Unit 1 folder, I apologize, covering the first part of Chapter 2. And where we had left off last time was actually a few slides beyond slide number 28, which you see here. But it made sense to me to backtrack a little bit and start there because that's where the real examples start. In fact, I might even go back one more slide to just review this concept because it's so fundamental and important. And then, as I mentioned to the people here in class just a couple seconds ago, make sure that you also have your SQL Server Management Studio open or whatever other tool that you're using to do this work. All right. The other thing that I did is once I open SQL Server, you'll get used to this, but you get that little login screen and you want to connect up to your database. And then I also went ahead and I expanded the tree here on the left-hand side so that I could see some of the Cape Cod database structure. And that way we can go in there and look at raw data, look at the tables, and just kind of be at the ready to do the work. All right, so the first thing that we're going to do is just jump back here really quick, and let's just talk about these three really important keywords once again, the select, from, and where. And if you walk away from this class and never touch another database again in your life, and you're like 20 years down the road from now, if you remember just these three terms, that's probably not a bad takeaway. For whatever reason, when I learned this stuff, and remember I kind of taught myself way back in the day, they stuck with me. So and it really helps me to this point because I can always think of it in that way. All right, so once again, the select is to choose which columns we're choosing, from which tables, and where will be the spot where we indicate any conditions if there are any. And of course this language does use semicolons as a delimiter or a termination mark for most statements, like a lot of old school languages do. All right, so we're going to try this example again, and I know we did it last time. So the funny thing is if you're going to watch these videos like after the fact, you'll notice there's a little overlap from the previous video to this one, but that's just how it goes. For us, a whole week has gone by here in the classroom. So we are going to start by actually typing these commands in directly, and in my case, if you see I'm smart here, I'm just going to grab the text right from the slide, and you know what? That's totally okay. It's totally okay to do it that way. But can somebody tell me, before I run a command inside of my SQL Server Management Studio here, what should I do first before I go paste that command in? Very good, Keegan. I'm going to use the use statement because right now my product here has actually 3 different databases loaded up in it. So if I ran the command, in fact, I think it's actually not a bad idea. Let's just drop this thing in here and see if it even works as is without using the use statement. But you notice all the red underlines already, and if you guys know any of the Microsoft products, especially their coding tools, red lines underlining stuff is very bad. And in fact, in many cases, you can just hover and it'll say invalid column name. But I'm going to ignore those. I'm just going to hit execute, and it is going to throw back an error message just like this. So it doesn't know where to find it. It's not linked up. So that's why we need that use statement. So I'm just going to click back in the upper part of the window here, and I'm just going to do a Control-Z to undo the paste. And then I'm going to type use, and what should I type now to use the database that we want to use? Yep. So I just use the name, and can I type it like this? Well, it's wrong for a couple of reasons. Well, I spelled it wrong for one thing. That doesn't help. So if I fix the spelling, will I fix it? Right. And you guys know. Yeah, I know you guys are catching on. Because I have this tendency when I teach coding classes sometimes to intentionally lead you astray to see if you're kind of paying attention or with the program, as they say. But also, by doing what I did, I'm also invoking the autocomplete or the IntelliSense tool that's built into the product. So as I was typing that, and you get used to this, you go past your keyword and then start typing a C, and it took a little while because the first time I started typing it, it didn't pull it up right away. Did you guys notice that? It's like the engine's got to wake up a little bit, you got to warm it up and whatever, but now it's pulling it up and it notices that I do have a database that starts with C, Cape Cod. I don't even need to type the rest of it. In fact, this is the kind of a hard thing to get used to when you use IntelliSense tools, when you've learned to manually code, to kind of let go of the steering wheel and let the autopilot take over. In the old days, I used to be kind of opposed to this. I would tell people that I'd rather type it out because it builds character. And now my attitude is like, oh, that's ridiculous. I'm going to use the autocomplete tool because I know I'm not going to make a mistake. And as a professional, it's totally what you would do. Why would you do something that takes longer and make a mistake in the process? It makes no functional sense. Now, if you notice, it wasn't highlighted, but I actually just hit my down arrow key, and now I'm able to select, and I'm going to press enter and lock that in. And then I'm also going to add a semicolon at the end, and then I'm going to go ahead and execute the query. All right, commands completed successfully. It now is basically just said, now I'm connected to this database right here, and all the subsequent commands will work attached to that database, even if I don't have the use statement up here. Now, some people, and I'm not going to, I guess, name them by name, but some people will say that you should put the using statement in, if you have multiple databases, on every SQL query. And functionally, I guess that's kind of correct. So like if I was to take this and save it as a file, a query I wanted to bring back, I would throw that statement in there because that way I could load it up and I could be ensured that I'm connecting to the right database to do it. So you can leave that there if you want. Okay, so you know what? Let's just leave it there for now. I'm going to paste this statement in now, and you notice how the underlines are gone because I've already issued the statement and it knows that I'm connecting to the right database. Now I can run this statement and it should work. And not to make it complicated or anything, but sometimes it's not bad to actually come in here and take a look at your database structure. Now earlier in our PowerPoint, I don't know if you guys recall this from last week, but the author goes through and he starts to detail like what the tables are, what things are in there, what kind of data fields they are, or data types. But you always have the capability here in the database product itself to actually take a look at the table we're interfacing with. So remember, the select statement chooses the columns, and then the from statement chooses the table. So I know that I can look for a table named SKU data, or SKU, right? And I can find it here in the tree under tables, and then I can also expand that and find the columns that are associated. So it looks like we have SKU, which is an integer. Now there's some other little indicators here which are kind of interesting. Does anybody know what PK stands for? It stands for primary key. Now we haven't hit that topic yet, but that becomes a very important topic later on. And every well-organized table will always have at least one primary key on it. And then what does not null mean? Yeah, actually it means the converse. Yeah, null means no data, but not null means, the inverse of that, right? So in other words, it's saying that that column cannot be empty. Right? Right. All right. Then we have another one here that accepts characters, up to 35 characters. A department also holds up to 30 characters, and a buyer that holds up to 35 characters. You'll see this FK, that stands for foreign key. That's another one of those topics we'll talk about. And none of them are good with the fact that you can have a null value. Oh, actually, that's not correct. Actually, the buyer can actually have a null value. I guess I didn't look at that very closely. So these first three columns must have data in them. So if you were to add data, those will require that data is entered in there. The last one doesn't necessarily require it. Okay, but it's probably good to put it in. All right, so we're going to go ahead and basically we're selecting all 4 columns, and then I want you to notice that we're selecting them in the order that they appear in the structure. So I'm going to go ahead and run this query, and at this point the query is, did you guys notice that since I was clicked over here I couldn't execute? So I came back to this window to activate that tab, and now the execute button appears. So I'm just going to go ahead and execute, and then we have our output down here at the bottom. Now I know that the text is really small, so maybe when we take a break a little bit later, I'll try to change my my settings here to make that look a little larger. But if you look really closely, you will see that I have all 4 columns, and it outputs basically another table. Isn't that interesting? And it looks like, it should look like this. So I'm coming back with 13 records. Hopefully you guys are too. Right? Okay. I'll assume that's a yes. Now notice with the tab, as well as we start working in this environment, right at the tip of where my pointer is right now, there's a little asterisk on that tab indicating that that query is not saved. And you notice that it actually auto-generates a name for the query, and they call it SQL1.SQL. SQL is the file extension on it. And if I wanted, I could actually come up here and do a save on it, or I could do a save as and save it under a different name. Now, I know we talked about that real briefly last week. Whether or not you really need to save a query is really kind of dependent, right? Sometimes you're just trying stuff. So, all right, well, I really don't need to save it. But sometimes that query that you create is going to be key to running an application. So you don't want to have to be in the situation where you're recreating it all the time. So sometimes you will actually save those queries and then pull them back by name. And then when you do start to do that, you know, I have strategies that I use myself to do, you know, the file naming. And I'm usually a big proponent of, you know, especially if it's attached to one database, to maybe include the name of the database and then kind of like what it's doing. So when I look at it, I can very quickly make a decision if that's the one I want or not. But that's really kind of up to you. You can name it anything you want. The beautiful thing is, it's just a text file. So if you have a SQL file sitting on your machine, you know, and I'm just thinking right now to myself, if I'm not mistaken, see, like, for example, right here on my desktop, you'll see that I have a script file that I believe that this is from, this is from my Java 2 class. And I have at least one person here, and maybe 2 people here in the class that are taking Java 2 with me right now, and another person that's already taken it with me. And this might ring a bell a little bit, but this is just a script file that came with their textbook from that class that's saved. And you can scroll through it, look at all the commands, and it also has all the data for building the database all built into one file. Could I pull this in to this environment, make a couple of little tweaks, mind you, and use the SQL code in SQL Server? Absolutely. Sometimes it takes a little bit of adjustment, but the truth is that it's just text. And yes, I could create it with any text editor and import it into the environment. This happens to be in Notepad++, but if I wanted, I could pull that same query. Let me see if I can actually do this here on screen, and pull it into the window, and you can see that it loads up. Now if I try to run this, it will error out, because you can see the first statement says use this, right? And that doesn't exist here. You know, that's actually a database on the Apollo web server. But I think functionally you get the concept. So I think that's an important thing to know. So you can bring in files, and conversely you can also take these files from wherever you choose to save them and take them to other programs and kind of do the same thing. All right, let's move on to the next one. And this one, you know, this type of query is one that you might find yourself using quite a bit. So sometimes you connect to a database and you just want to see what's in a table. Heck, I don't even know what the column names are because I'm not smart enough to look over here, or you're too lazy, right? And sometimes, you know, depending on the product you're working with, you don't want to go navigating a tree. You can just do this, and it's going to select all the columns from this table. There's no where statement, so we're not filtering for anything, basically. We're just going to run it, and it's going to pull everything back there is. Now, do you notice that we got the exact same results? All right. Now, I would say that one approach is functionally better than the other. It's always better to name your columns. But this works too. But if you don't know your columns, here's a way you can learn what they are. And then once you know them, you have them, and you can proceed from there. Now, if anybody, as we're doing this, folks, if anybody runs into a command that doesn't work for them, let's figure out why. Okay, so don't just sit there in silence going, you know, I'll figure it out later. No, let's figure it out now and make sure that it's right. All right, next slide. The next command is kind of narrowing things down a little bit. So in this example, we are actually going to select specific columns. And this time I'm going to be really brave and I'm going to remove the use statement from the top. I'm just going to paste right over it. So you see, now we're going to select the specific column. So we're going to select department and buyer. And we're going to pull it from the same table. And then you notice it just pulls back those two columns. And then if I remember right, the next slide has us change the order. So you notice that? So I can just do that manually here. So why don't we take buyer and put that, oops, not what I intended to do. Okay, my copy pasting is failing miserably here. And I don't want that extra comma at the end here either. Okay, so by just simply changing the order, it'll change the order of the output. So in essence, what this is saying is it doesn't matter what order they're actually built into the table. The database engine can pull it out and then recreate the columns in whatever order you designate. Pretty simple. Here's another thing that just popped in my head just as an example, because our book shows select from and where, right? And you notice that all the statements we've had so far, select is on its own line and from's on its own line. But a lot of database people wouldn't do it that way at all. They would put it all in one line because you know what? See the semicolons at the end? That really functionally is one line of code. The reason we're splitting it like this is because for our brains, it's a lot easier to kind of organize it and see it. So that it also tells you that the white space and the carriage returns in the code that we're typing are not important to what happens on the output. It doesn't matter if I move this way down here and run it, it's still going to run the same. Or if I decide to move it over. Okay? We'll stick with the format for now. But eventually, we'll probably get to the point you'll start to get comfortable with it, where you're going to make these really long strings, and it kind of doesn't really matter what the layout is. It's whatever your brain is comfortable with. Now, what's kind of fascinating about this is I have a close friend of mine that's learning how to code, and they're actually learning HTML, right? And you learn that in HTML too. That's like, you mean I can put it wherever I want here? And it's like, yeah. Wow, it's like a revelation, and if you've been doing it for a while, you don't even think twice about it. All right, next. All right, let's actually talk about this. They go through here the next series of slides, so we're going to be kind of skipping over a couple of things and talk about how to do to tweak a couple things inside whatever environments you're working with. So the first couple relate to access. Now the reason that they bring this up here, and we got to have kind of a functional understanding. When you work with Microsoft Access, there's so much that you can do in Access where you do not need to touch any SQL code at all. And that's why a lot of people use that tool. So it's possible to create a table and an interface to enter the data into the table, set up all your relationships, your joins, your keys, and do it all graphically. Drags and drops, menu selections, etc. And then the only time you really need to get to a SQL window is when you're trying to do something really custom that you're struggling to do from an interface. But having worked with that product, and I don't know how many of you have ever touched it, there are functional ways from the graphical interfaces to do just about everything and create the SQL command automatically in the background with you not even messing with it. But then you're not really, in my opinion, you're not learning how to really program or do database work at that point. And there's nothing wrong with that approach, frankly. And it works for a lot of people. But you guys are going to get paid a lot of money because you do know the manual approach. That's where the money is. Right? So they go through this whole thing about showing you, how to run a query, how to bring up the query window, and then once you have the query window, and see, this is what Access does for you. It's like, well, what fields do you want to pull in? Well, here's my table. I'm going to come down here, and I'm going to choose the field I want and say that I want this field to equal this amount, and it'll just do it for you. And then in the background, it's building the query statement for you. Now, it's kind of neat, because if you're learning, the one functional cool thing about that is it will show you, like, you can logic through it in your head, but you're not sure how to do the SQL code, so you can choose the right stuff from the boxes, and then you can look at the SQL command and go, oh, okay, I see now what that means. So from that standpoint, it's actually, I think, a positive. And so they go through the whole process here, but there is actually a query window where you can manually type the stuff in. And this series of slides is basically to show those people using Access how to get to that point. So I'm not too worried about those. However, this is the product that we're using, and you need to familiarize yourself with this environment. Now, we've already, I think, hit upon a lot of these things without really formally talking about them. And I think that's, frankly, when you're learning a piece of software, you might have two different feelings. One is an extreme intimidation with the complexity of whatever you're looking at, right? Now, I get the impression most of you have done maybe a little bit of this kind of stuff before. Is that true? All right, so you're not all freaked out by it. So it's not that weird. But if you are brand new to the environment, I would strongly urge you to look at these sections really carefully in the book and examine these slides, because I think it's very helpful. We've already discovered that we have the Explorer tool here on the left-hand side, sort of like a file manager, but not really. It's really like exploring through different object structures, basically. We have our text window, our output window, and then, of course, the ability to execute our code. Does anybody know the shortcut key to do execute? F5, right? And that's a real common one in a lot of IDEs. And although I guess this is, I don't know if technically I would call this an IDE, it really in essence is an IDE. It's really a skinned version of Visual Studio is what it is. So kind of like a custom implementation. Next thing that they show you here is how do you go ahead and save a file. And I think I was, I guess, kind of on the verge of doing that. So if I wanted to save this, I would just come up here and choose dialog to save it under the name given, or do a save as, which is the one I recommend most of the time. And then if you want to give it a certain name, you can type in something, hit save. I'm just throwing it on my desktop, I'll delete it later. But now it's saved. The beauty, of course, is once it's saved, I can also come up here and open it. And I'm just going to open a file. I'm going to go to my desktop where I threw it. What did I call it? ASDF, something like that. There's a SQL file, and open it. And it comes back. Right? So it's not a big deal. But at the same time, if you've spent a lot of time working on something, you need to shut your computer down and come back to it, you can do that. Or, more importantly, if you write a query that works, and then since you guys are all learning to be programmers, hey, I've already got a query written that selects buyer and department, and now I'm writing an application that needs that information, I can just pull this code up and drop it in in many cases, directly into my application that I'm building and go from there. So I think that's really an important feature. So that's how those couple of tools work. We already saw how to run a query. You know, they do a complete breakdown here of how to do that all, but I think that you guys are functionally okay here. And then, oh yeah, these, okay, so notice I've actually switched over to the Oracle environment here on these slides. And so you notice like even Oracle kind of looks the same like SQL Server. They're so similar in appearance it even fooled me just now. Right. So like once you get to know the one tool, you're kind of in the same boat with the others. Very coincidentally, you can also work with MySQL, another major database project. It's basically the free version of Oracle with not nearly as many features. Very coincidentally, if you are all web students, and most of you should be, I do get data analytics students that will be taking this class too. But if you're a web student, one of the things that we do in the web class is, and you guys aren't, actually I'm looking at stuff on my other screen here and I'm realizing it's not recording, but here it is. So if you operate on the, if you have an account on the Apollo web server, which is the web server we're using spring semester 2020, and you get, I think it's when you get to maybe your second semester, you take your PHP class, and about halfway through, or maybe 2/3 of the way through that class, your instructor will create a MySQL database account on Apollo for you. And then when you want to access that database, the Apollo web server has a piece of software on it called PHP My Admin. So all you have to do is append that to the Apollo name, and it'll bring you to this interface where you can log in. I'm going to go ahead and log in, and not, I don't want to like bombard you with too many tools, but I just want to show you that if you're a web developer, this tool might be the one that you use the most out in the field. In fact, when I was a freelancer, it's basically the only database product I used almost the whole time. Because most of the stuff that web developers do is they'll go in there and maybe add a little data, or add a column, or change a couple little things. We don't really do really heavy database stuff typically. We're usually writing stuff to a table and pulling it back. But the fascinating thing is, whatever database I happen to be working with, so I'm just picking one from like a PHP class, they also have a SQL script engine here. So I can actually come in here and type my command. So I can type, select. Notice how, even, this is in the browser, folks, right? I can type a select statement, and I can do this. Select star from, what do I want to, well, I don't know. What tables do I have? Well, I guess I need a table with something in it. How about interviews? Interviews sounds good. Oh yeah, but see now, see what database it's trying to pull it from? You see that? So that's not going to work. So I actually would have to maybe switch. Yeah, go ahead and switch. And let's try that select statement again. So let's try select star from, what's the name of the table? Interviews. See how it auto types here? I put in my semicolon. I come down here and hit the go button, and then it outputs. You can tell it's mine because there's a bunch of nonsense stuff in there as a demonstration. But you see that you shouldn't be intimidated. So any database product that you walk up to now, you should know that you can go up there, find where is it that I put in my SQL code. You can probably Google it really quick, or like this one is right there for the taking, and now you can start creating queries in just about any environment. Isn't that cool? And yes, the Cape Cod database can be loaded into here too. And if you're enterprising, fantastic. And that kind of goes back to my whole point. As you go through this class, you could hypothetically try the examples or even your exercises in other environments. And then towards the end of the semester, there's going to be a couple instances where I'm going to push you to do it, just so you have the experience. But then you can walk in and say, yep, I know SQL Server, I know Access, I know MySQL. my instructor talked about Oracle, but I know I can figure it out because I know the other ones. And you know what? They will believe you. So hopefully that's a little bit enlightening. Now the MySQL environment has another tool, and sorry for the sidetrack here. Actually, they show it right here. This product right here called MySQL Workbench, which is a free piece of software that you can download from the internet that is a standalone product, doesn't run through the browser, and you can notice how the interface on this is very, very, very much like the Oracle environment and the SQL Server environment, right? You would figure it out very quickly. Very, very similar. All right, let's move on from that. Now that we have that kind of out of the way, now let's turn our attention to this next batch of queries here. So we're on slide 47. We only got how many to go? You see how long this PowerPoint is? This is like the PowerPoint of horror, folks. Oh my God! It's only 50 slides to go. All right. I want to, you guys notice like the top line of this? How it's got all those special characters? That's a comment, exactly. And do you guys notice? Now, I know everybody in here is a web student. What is that? What commenting structure is that similar to?
Java.
Yep, it works the same in Java, and
And you were referring to, does it include everything, or just one line?
well, this format is actually, it works in so many different languages. That's the right answer, Vaughn. Absolutely, it works in so many different languages. But I typically refer to that style of commenting because I first learned it when I learned CSS as a CSS style commenting, and it allows for multi-line commenting. And guess what? Another thing that you can do is the same thing we can do in Java and CSS, which is 2 forward slashes. Same thing works. So, you know what, folks? That's actually a little bit of a clue as to the languages that are used to develop the other languages, and that's a mind blower too, because any language you work with is always developed with another language. It's kind of like which came first, the chicken or the egg? So what was the first language then? Well, that's the real question. It was the ones and the zeros came first. All right, let's take this whole thing though, and let's put it in here. And the next thing that they're going to do is they're talking about this thing called distinct. And let's paste it in, and then you tell me what it's doing. So we're saying select distinct buyer and then department. Is this giving us a different output than the command that we just ran? You're not sure? Well, we can remove it and run it again. But why are we getting 13 entries here? So we got like for buyer. Bingo. Spot on, Keegan. Very good. Yeah, it gets rid of the duplicate. So it's like, in other words, anytime the SKU table here, one buyer might be connected to many entries, but I just want to know how many unique buyers there are. So there's a very simple command for it called distinct. So it's a very useful command. So once again, the regular version gives you every entry, even if it repeats. When you use distinct, what did I do wrong there? I'm not sure what I did wrong. But when you use distinct, it finds only the entries that are unique. But let me ask you this. When I do that, so let's get rid of that again and run it one more time. What is it also doing? Okay, that's true. That's a good observation. But here's my concern with this. If the buyer, right, Pete, who's in the water sports department, Well, I guess the other thing that's happening here is like, I can have more than one buyer in one department, but it doesn't seem like that buyer can buy from multiple departments. So I was looking to see if like maybe Cindy was, you know, for camping or water sports. Then the question becomes, if she was in two departments, which results would come back? All right. That's an interesting thought, right? We can also take that distinct term and, you know, if you want to play with it a little bit, you could put it in front of department. Well, you notice what happened there. Now, why is that wrong? Yeah, that's exactly right. So in other words, this keyword is looking for things that are unique regardless of the number of columns. So in other words, if I did have a person that had multiple departments, it would list that person twice with each department. So it's a combination of those things. But if you have a lot of duplicate data, and that happens a lot in databases, distinct helps you with that. Let's just run it one more time just to show it. Now, of course, you know, in subsequent chapters, you're also going to learn when you have repeating data, sometimes that's an indicator of other issues too, or the fact that you might need to kind of streamline your database through a process called normalization. Okay. Another built-in little tool that they have here, and they call this, what do they call it? They call it a function, okay? Just want to make sure. And it's a little function called top, and then followed by a number. So they're saying top 5 buyer and departments. Let's run that and see what it does. So what would you say that's doing? If you guys are remembering the output of the previous queries, and you know, here's where it gets interesting. So if I'm going to actually create a new query because I've been working in one window this whole time, and the reason I'm doing this is to show you the functional difference here. So I'm just going to copy this, go to that new query, paste it in. I'm going to remove the top 5 so we get all the results and run it, and that way I can switch between the two and look at the difference. So what is top 5 doing? Yeah, it gives you the first 5. So what's the logical question? If there's a top, is there a bottom, right? And that's the kind of, I'm hoping your brain thinks that way. That's not where their example goes next. It actually goes to the top 75%. And I think it's fascinating that, you know, whoever developed this, you know, wrote it out like that. Well, now I got 2 comments. Isn't that wonderful? But in this case, the top 75%. So if there were 13 total rows, how many should it show? So here's, and I'm trying to be a little preemptive here. I'm going to pull up my calculator, and I'm going to say 13 times 0.75 equals 9.75. So how many is it going to show? 9 or 10? 10? All right, we'll see. You know, it's good to know these things, though, because it does return 10. Now, you know, my logical question is, what if my calculation yielded 9.4? Still 10. It's going to err on the side of caution, basically. All right, next example. All right. And wow, this is our first where statement. Ooh, this is exciting. So let's go back, and I'm just going to replace that. And so once again, we're back to the asterisk for select. We're going to choose from the same table, but this time we have a statement that looks a lot like a programming statement, right? So department is one of our columns, and then we have an equal sign, and then inside of quotations, notice this is single quotes, a string that says water sports. Now, we know that's already in there because we can look at the previous output. But let's go ahead and run this query. So now it's going to pull back all the columns from the table where the criteria is met. If I change that and run it again, what's going to happen? No output. Notice it did run it. It gave me the columns, right? But no output because it must be exact. Okay, let's test that. What if I change that to a lowercase s? Okay, I got slightly different. Interesting. So what is this telling you? Not case sensitive. You could also wonder, can I force it to be case sensitive? That's a separate issue. Let's talk about that at a separate time. Let's stick with what we're learning right now. So that's a very useful command too. So you're going to type a lot of things, and I want you to contemplate this when we're doing any where statements. If you think about when you go out to Google and you type in a search query, right, and you put in a term, really the query is what drops in here, right? So like what you're putting into the search window is the where. Search the whole internet, right, basically, to find that. And so this is, in many cases, when you're application building and you give your user the ability to do a search on your database from a front-end interface, whether it's a operating system native application or a web application, often you'll set a variable in this spot and then feed data into the query via the variable and have it search your database. Isn't that cool? Yep, and those of you in the Java 2 class, we're going to be doing that. It's only weeks away. And it's a whole lot of fun. At least I think so. All right. Now, as we did this, you'll notice that there's an equal sign in the statement. All right. When we look at programming code, typically, and we have something that has an equal sign after it, usually in a regular computer language, the thing on the left, is the variable name, and the thing on the right of the equal sign is whatever we're putting into it. That is not the case here. This is much more like a proper equal sign in that is, what we're searching for. So in other words, that's what this next slide is about. All right. So in a programming language, a single equal sign means assign this value to this variable. It does not mean 1 + 1 = 2, different in a programming language. Now here we come back to SQL, and it's back to math. That's the point. So what we're saying is a single equal sign is equal to. I want you to notice how they do not equal. You see that? Okay, so those of you that maybe somewhere in your past lives or current lives maybe learned how to do Visual Basic programming or even basic programming, that's the not equal to sign. Many programming languages to do not equals do what? Yep, exclamation equal. But if you're a Visual Basic person, you'll recognize that as a not equal immediately. That is a little quirky. The less than and equal than or less than and greater than, and then with the equal sign, those are similar to the other programming language constructs. But then we get into these other operators here that are kind of interesting, and yes, they are strings, and in some cases, multi-word strings. So it says in is equal to one set of values. Okay, so the example there, and primitive as it might be, and we're going to see more examples below, is if I have a list of numbers like 1 through 10, And then I do a where statement that says, you know, is the number 5 in that list? And listen to how I said it. Is the number 5 in the list of 1 to 10? It sure is. Okay, so that's kind of how that works. And then not, of course, would be the inverse. And then you can find, like, you can actually look within a range of numbers or the converse, so they have between or not between. And then we have this statement, which I find very, very useful, like and not like. So in other words, matches a sequence of characters. So if I had, let's say, I'm looking at the Foxconn logo on the wall here, right? If I say, is the word Fox like Foxconn? Well, not, I mean, it's not exactly, but Fox is part of it. And so that allows you to do kind of these like weird granular searches, and with the inverse too. So you can kind of make these interesting inclusions and exclusions. In addition, we have the null statements, and null means, well, is equal to null. Okay, well, what the hell is null, right? That's the logical question, and the logical answer is null is basically kind of the absence of anything. It doesn't mean zero. And it also doesn't mean nothing. Okay, and that's where the confusion comes in. So null basically means there's an absence of anything, including an indicator for nothing. And that's a really hard concept to latch onto. But the way that I always think of it is nothing is actually something, because otherwise how could you give it a name? Null is actually truly nothing. You know, that's kind of how I think about it. It took me a long time to kind of latch onto that. But in terms of databases, the concept of null is basically that some fields do require that they have data, and some fields don't. It's simple as that. All right, we're going to take a really short break here in class, and we're going to come back and pick up with the next set of examples. All right, let's go ahead and try this next example now. So we're on slide number 52, and we are going to run a couple of commands. And the first thing I'm going to do is I'm actually going to modify this a little bit. And I do have a strategy, and I want to show you what it is. So the first thing is I'm going to come back over to SQL Server, and you know what? I am going to Control A, Control V, and put in the query that they want. But I'm actually going to remove the where statement for right now. And yeah, it's okay that the semicolon's on one line. Why am I doing that? I want to see what's in that table without any filtering. All right, and then I can use that as kind of a baseline. And since I'm like running 2 tabs, I'll move this tab over, and so I can always come back to this one and say, is that actually true? Now I'm going to come back to this one and paste back the, well, now I gotta get the whole thing again, right? Paste back the whole query with the filter, and I'm going to run it, and now I can see, is it the same list? I know it's not, right? You see how it changes? But here it says date on website. So I have this new table we're working from, so catalog SKU 2017, and here it is. Here's my columns, just for reference. And I'm selecting all the columns, but at the same time, I'm only looking at date on website as 01 January 2017. And that's the format that you're picking it in. Now, here's what's fascinating about this. First of all, notice how we put the date in, right? Might not be the way that you think about dates normally. So what's the first 2 characters? The actual day, right? So this is more of a European date format than an American date format. So we start with first the date, the month, and then the year. And the month is designated by a 3-letter term, and then the year with 4 numbers. separated by dashes. But then when I look at the database data, the format is different. Oh, great, right? I mean, that's kind of like, you know, it's like, so what is that actually saying about this piece of information? Well, if you look at the data type, now we haven't talked formally about data types yet, but you'll notice that the data type for date on website is in the form of a date. So regardless of how that data is displayed, the system saves that data information whatever way it saves it. I'm not even sure how it does it exactly, but it can be translated from this format to this one. And I can still query on it. It understands it. And I think that's a really important distinction. So that's a, you know, and that's not really, I guess, the main topic here, but it's just showing you how to do a where clause with a date, and you totally can do that. The next example goes back to the original table we were working with, the SKU data. And in this case, we have a greater than sign in there, and that's going to pick any of the SKUs that are greater than 200,000, right? So this is a 6-digit product code, so anything from 200,001 and above should appear. And if it had a SKU of exactly this, it would not appear. That should be what happens. Okay, I'm not sure what happened there, but you know, sometimes I try not to freak out and I just do it again. And this time it works. It's good to know. I have a suspicion as to why it happened. Because it did work from one, it was working with one table, and then I switched. Okay, so maybe that's an aspect. But if something, you know, it's just another tip. If something fails, don't just take that first failure as like, okay, that's it, I'm done. You know, it's not how it works. You know, so just go ahead and give it a try. So, are all those numbers greater than this? They sure are. Next example. How about we run this one? Now this one's interesting in that we are once again calling specific columns in a specific order, but we are looking for a department called climbing. Running a query, and is that correct? Yes, it seems to be correct. Now I could go back, you know, I could run a query where I eliminate this statement and we just look at all the departments, right? In fact, what I want you to try to do is you should start intelligently thinking about it that way, because this is those two columns of all the data. Then I can actually come in here and if I want, I guess manually count. But really kind of the point of doing the database work is you don't want to manually count it, right? So here's that error message again, right? I'm running it again. Maybe if I click it faster, it'll work. Yeah, I say I'm not really sure what did I break here with where. I don't see that I broke anything, but let's try it again. You guys see what I did, right? Somehow it by deleting that piece and putting it back in, something didn't work quite right. All right, but now we know that that's right. But if you're working with a data set that maybe has 1 million entries, you have to trust your database engine is what it comes down to. You can't always verify every little piece of data. Slide number 55. All right. That's the same slide we just did, right? Yep. Right? Oh, I see. We were changing. Okay, I see the difference here. So now we're going to really what we're doing is we're modifying this query. Notice this one before I paste in the next. one more time. What changed? Yeah, so department changed to buyer. However, we know from the select statement that those are the two columns that we're going to see. But now I'm doing a filter, or like choosing something based on this criteria. Oh, this is a wonderful little example here too. See what happened in the copy paste? You see how like huge I'm making this obnoxiously? Do you guys see that this is different?
Yes.
Now that happened because I was copying from a PowerPoint and he had a smart quote in his PowerPoint. So I need to actually fix that. That's why it's underlined. And there we go. So let's go ahead and run that. So I'm going to show two columns, but I'm filtering based on a different column that I'm not even seeing. Of course, you could verify that it's working correctly by adding department to the list in the query. Oops. And now I can see that department actually matches, but there are times where it doesn't really matter if you see it or not, right? You take it on faith that it's going to pull up the right, because there we go with that thing again. Oh, and I know what the problem is. Space, maybe, right? Oh, the comma, yeah. It's always the little things, folks. All right. So we know now because we verified that it's actually pulling the right data. Let's move on to the next one. Now we're going to add a new wrinkle. So we've learned select, from, and where. Sometimes you skip the where or include it, and then whatever output you're coming back with, you want to filter it and sort it in a separate kind of way. In this case, we're going to use a statement called order by. And this one allows us to put the things in a particular order. And maybe my font size is maybe a hair too big. So we're going to select all the tables from order items. So let's, where is that? Right here. Okay, there's that table. Take a look at our columns. Got order number, SKU, quantity, price, and extended price. So we're going to select all those columns from that table, but we're going to order it by order number. And so that will automatically pull back the results and then sort them based upon the number of the order. So, you know, a lot of order systems, especially electronic ones, will sequentially number invoices, right? And I used to have the thought here at Gateway that when you came in and you got a student ID number, that, you know, all right, you know, my ID number is 1001 and yours is 1002, you know, but that's not at all how it works. And the reason I learned it works a completely different way is, I mean, in the old days I think they did it that way, but new ones are actually built around some aspect of your name. Because when my son got an ID number here, his was almost identical to mine. Started with the same numbers, just a couple different digits in it. And I was like, well, isn't that interesting? So there's some algorithm that they're doing in the background to do that. But notice that these are ordered by order number. Isn't that interesting? Now, why would they have like two different SKUs on the same order? Nobody says you can't order more than one thing on an order, right? It doesn't have to be unique. That's thing there. What about this one? This one actually has two ordering criteria. So we're going to first, notice how I said that, we're going to first order by the price. And what do you suppose DESC stands for? Descending. So would that be from A to Z or Z to A? From high to low. So if it was, you know, 1 to 100, it would start with 100, for example. Okay, and then Order number, ASC, would then stand for, right, so it's descending and ascending. And let's run it and look at the output. So, is it first ordered by the price descending, the highest of the lowest price? Absolutely. Is it then ordered by order number ascending? Well, that gets a little trickier. So we have to find things that are the same price. So here's 4 things that are the same price, right? And then the order number is ascending. So it starts with the small one. Okay, that makes sense, right? So it's the smallest and goes to the biggest for all of those. But the price is sorted first, and then the second criteria. And that can be very useful. Order by, like, just ordering by last name, for example, is a real common query. Like if you have a list of people, so you get them in alphabetical order by last name, and then if by some chance you have a bunch of people that have the same last name, then you order it by first name. Right? All right. All right, let's move on to this next slide. Here's what they start to talk about. Wait, it does not want me to click on that slide. What we call logical operators. So all of you that have done some programming, and that's everybody in this class, have probably done conditional statements. So for example, if you learn Python or Java, you may have had, you're running an if statement and you say if x is equal to 10 and y is equal to 5 or something like that, and your ands and ors. And we have those structures here in SQL as well. So that's important to know. The meaning is essentially the same and implies that both conditions that you specify are true, or only requires one to be true, one or the other. They can both be true as well, but at least one has to be true. And then not is basically the inverse of whatever we're putting in. So like you might say that this is not something. All right, let's try the examples. All right, back to that SKU data table. All right, so this one says, select all the columns from SKU data where the department equals water sports and the buyer is Nancy Myers. Now I'm getting some flags here, and I'm wondering, it says incorrect syntax near Nancy, and it says unclosed quotation mark after the character string. I'm not seeing that, but since I am copying and pasting the stuff, and of course this is where my browser goes into not responding mode, or my product does, whatever that is about. Oh, very good catch. All right, so that's not where the error was. Excellent catch. Thank you, guys. And there we fixed it. Now, do you also notice that it doesn't really care if I have spaces in these spots? Do you guys see what I just did? So you can actually do it without spaces or with. And my tendency typically is to put extra spaces in because it's just more visually comfortable for me. But some programmers squeeze the space together and make it more efficient, I guess. So let's run this one. So the department equals water sports and the buyer is Nancy Myers? Yes. All right, let's try an example of an or. Now, this is a little different. So, from when you're coming from a programming world, now we got that same little curly quote thing going on here. When you're coming from a programming world and you think of how you use an or statement where one or the other is true. In this case, we are looking at something that's a little unique, right? So there's not going to be the case where both of these are going to be true probably ever. Can you see what I mean logically? So because we're pointing both to the same field and we're looking either for camping or climbing. And chances are you can never use an and here and pull back any results. Depending on how the database is structured, of course. So, are we pulling back only things that are camping and climbing? Yes. Right? One or the other needs to be true. Let's go ahead and try the not operator. And notice the not operator, because it's doing what we call negation. There's that curly thing again. We do have to combine it with one of the other operators. So we're saying where the department equals water sports and not buyer equals Nancy Meyer. So we want water sports, but we don't want this person to come back. And there you go. All right. Let's move on to this example now. And now we're going back to some of the other operators that we were talking about earlier. And I want you to notice how this one's laid out. And this is kind of interesting because, copy paste gets this thing moving. So I'm adjusting that. And so here, when we use the keyword in, we are looking to see that as we go through the table, we look at each buyer, and we're trying to see if that buyer is part of this particular data set. And in this case, we're actually specifying it in a list. There are circumstances in which, instead of a list of people, you might actually have a query or pointing to a different structure in the database to pull that information in, but in this case, it's written out in plain text. So we're saying, we're going to select everything as long as the buyer is one of these three people. That's really what it's saying. And there you go. So is it Nancy Myers, Cindy Lowe, and Jerry Martin? Yes, it is. Next example. This one does the converse. So as long as the buyer is not in that range, once again, should I leave the spaces in and see if it finds it? Yeah, you know what? Sometimes that's fun to do. See if we can make a break. Now, I adjusted it before, right? All those extra spaces, because as a programmer, I think of a string as this like solid structure and that everything in between is important. But what this is telling you is that it's kind of ignoring the white space. Yeah, so it kind of behaves almost like HTML. It reads one space but not more. So it really kind of handles the data in a different way. Here's where a query gets a little more complicated. And at the same time, I kind of consider that kind of complicated more fun. That's me. So we're going to pull back all the columns from the order item table where the extended price is greater than or equal to 100 and it's less than or equal to 200. And after we bring it back, then we're going to order them by extended price. Let's go ahead and run that and see what the output is. All right, so here is the extended price on all of these greater than or equal to 100? And less than or equal to 200? Absolutely. And then are these ordered by extended price? Yes. What if we changed it and then just order by price? You notice how this price right now is out of sequence? So then I'm going to execute that. And now it's in order of price high to low. And what if I wanted to switch that around and instead of going ascending, I wanted to go descending? Where do I put the descending indicator, before or after? Well, after the buy, but before the price? Okay. This is my test to see if you guys read. Okay. Well, the worst thing you can do is fail. And so could I put it here? That looks right. Okay, so that's our little lesson there. But you know what? No harm done in trying. You figure it out as you go. And now we have the right criteria, and then we're sorting it by the inverse. So descending the highest price first and then flipping it. All right, let's try this next query. This is a fun one. I say all of them are fun, don't I? Eventually you'll stop believing me. And I'm just cleaning this up more for my own sake. All right, so it says select all the columns from order item where the extended price, so here's our keyword between, and another, the combination operator and, so we can use this syntax. Now, isn't this functionally the same thing that we just did? Yes. But notice this, so this is a hard leap for programmers because as programmers, what we learn to do in a regular programming language, and this is why the author shows you this, right? Just in case you've done programming before, right? We always teach you programming before we teach you databases. When you do, like an if statement and you want to declare a range, right? You're looking for something within a range. You can't, there's no between keyword in a programming language. And so we have to use greater than or equal to and less than or equal to, and that's how we do a range. But in this language, you do have this between keyword that some clever programmer added into this a long time ago. So this functionally does the same thing that we just did. But I think that's a really important little one to know because I find it very, very useful to be able to do that. The syntax is more concise, and any database guru will always go to this first because they're not thinking like programming people, they're thinking like database people. There's a little bit of a difference between that and a regular language. We can also do the converse. So I'm not actually going to run this one, we can just look at it. So if I wanted to pick the stuff that is not between, this is also more efficient than programming, right? So in a programming language, if I want to exclude something in a range, I still have to do an and. I have to flip the signs on each one of the statements, but I still have to do an and. I have to do two separate statements to make it work. Here once again, it's a range. Yes, I can do the inverse. So now it's not in the range, so I get whatever before it and whatever is after it. Nice simple little clause. All right. Let's talk about this next little tidbit here. So it says the SQL like operator and SQL not like. So these are the ones I mentioned before. Can also be used with what we call wildcard characters. And this is, I think, a pretty important one. In many cases, so, when we've done this, and now we're thinking as, hold on a second, I thought that was the wildcard. I hope your brain said that, right? It's like, wait, so I can select any column by doing an asterisk, but now all of a sudden I can have wildcards that are underscores or percent signs, and that's a little confusing, but they do have special purpose, and that's why they have these different operators, and I think it's kind of useful to know. So it says the underscore, it represents a single unspecified character. So for example, if I wanted to look, Nancy, if I wanted to look for somebody that has N-A-N at the beginning of their name, right? Or, I don't know, maybe there's Nancy's that spell their name with an I-E, or two E's at the end, or who knows what, instead of the Y. I can put a wildcard character in place of the Y, and then it'll find everything that meets the other criteria. But this is really useful because you can really kind of like get really specific and granular with snippets of text, and I think that's really kind of cool. The percent sign, unlike the underscore, actually will take any sequence, and notice how they word it, any sequence of contiguous unspecified characters, including spaces. All right, so this takes a little, let's take a look, for example, and then see what the results are here. So very often, when you're doing these like statements, you find yourself throwing in wildcards, because if you think about what like means, it kind of implies the fact that we have uncertainty in what we're looking for. Okay, so it's like Pete but it's not necessarily. So let's run this. And then when you look at the output, well, it actually does say Pete, so I mean, that's actually exact. But it doesn't specify the last name. See the difference? Okay. What if I remove the % sign and then run it again? Interesting, right? I'm going to guess it's not what you would anticipate. Certainly I didn't anticipate that, but the wild card, so any series of characters, not one, but many, that would fit. So it would pick up the space and the last name and pulled it in. And we run it again, static query in there. All right, next one shows wildcards at the beginning and end. And yes, you can do that, so you can throw more than one wildcard in. Yeah, so I don't know if there's like half dome and a half dome wide and a tent vestibule. So if anything that's got tent in it. So you,
Is that case specific?
very good question. So it was asked, is that case specific? So I'm changing it to a lowercase t? Not case specific. Right. Interesting. Okay. How about this one? So this is another like statement, but now we're using the underscore, and this is kind of double bizarre, okay? So now we're looking for a SKU that is like, right? So the wild card says anything can come before the two, one or many characters, but the things at the end here is this one character or two, that's two characters, followed by any two characters. So really what, the way I read this is something that's got a 2 in the third last position. That's how I read it. Right? Let's run that one. Interesting. Is that correct? Yes. Now, seeing the output there, could I do something like this? See if it comes, I don't know if it'll come back with different results. It's not. But I can look for one specific one. In that case, they were looking for two specific ones. Fascinating. All right. How about this one? So we are looking for null in this case, where the catalog page is null, and that's catalog SKU 2017. All right, so which catalog page? Right, so this one does allow for null. Do you see that? Now this would not be logical to run on this table, or this column, excuse me, because null is not even allowed. But on this one, it is. And that's why those little indicators I think are very helpful. And I don't know if you guys noticed this with the other database engines. Not all the database engines necessarily, okay, what are we doing wrong here? Near the keyword is, okay, line 3, I don't see any problems. Sometimes just retyping it helps. Okay, there we go. So apparently this one has a null catalog page entry, so it's not in the catalog. You have any products that aren't in the catalog? Yes, here it is. Right? Maybe they sell it in the store, but not in the book or online. I'm trying to think of a scenario there, okay. And then you can also do the not null. I'm not going to run this one, right? So anything that does have the information will pop up. All right, and of course, they have more stuff for us. So here's where we get into some, fancier little routines here. So in this case, they're talking about what we call aggregate functions. And let's take a look at what they do. So we have this one syntax that says count, and then inside parentheses a star. And what that does is it counts, you know, as it says, count the number of rows in a table. Might that be useful? Sure. Maybe I just want to know how many customers I have. So you just count your customer table. Oh, I got 5 billion customers. That's great. I'm rich. All right. Next one says count, and notice how they have this name thing, and it says count the number of rows in the table where the column name is not null. So what would you put in the place of name? The name of the column. See what that implies? And I think here, I'm not sure why that square bracket's there. I think that's just a typo. Okay. So you're giving, yeah, I saw that look and I was like, yeah, I did the same thing. I'm like, typo. All right, we also can do, and these are really cool. So as programmers, right, once again, we look at sum, average, min, and max. And what I'm hoping that you recognize here is that those activities in terms of working with data are so common that, like for example, if I was working in Excel and I type up a column of numbers and highlight them, it automatically gives me the sum down in the title bar, and the average, and the count. Right? Very common functions, and those are also built into this language. So I can, you know, take maybe all the stuff that's, you know, maybe like inventory numbers and add up all, how many products do I have? Or I guess I have 65 million products by just doing a sum. That means I can easily figure out the average price of something, or what's the lowest priced item, or what's the highest priced item with min and max, and it's built right into the engine. And I think those are very, very useful. And more importantly, those functions, you know, going back to that, this gives us the capability to do what I call something like almost programmatic while we're doing a search, right? So why that's important, here's why. So when database people build tables and databases, sometimes they build databases that just hold the information. They have no concern about doing any mathematical manipulation with it, okay? And here's the why. Some people dump the stuff into a table, pull the information back, and then use a different application to do these functions, right? And there's probably functional reason for it. But at the same time, if you can do it with your database, that saves you a step in programming. And there's two schools of thought. Is one better than the other? Database people always say it's better to do it in a database. And then programmers will say, why would you waste all that processing power? Just store the data, we'll do that in the front end. So there's schools of thought on this too, so just so you know that. And it's one of those epic, you know, programmer versus database admin debates of all time. But the truth is you can do it either way. All right, so let's take a look at this little example because I think it helps to kind of explain how it works. Now, they did talk about sum, but they didn't like really show the syntax for it. And so notice now how we're pulling this in. So it says, well, first of all, do we have a table called retail order? We sure do. So here's retail order. And once again, this is just me being maybe a little obsessive, I guess. But I always like to see what columns I'm working with and what, you know, data I'm manipulating. But if you look at this, we are looking now at a table. It says retail order, and I have order number, store numbers, store zip, order month, order year, and order total. But the select statement, I mean, it does kind of imply which column we're looking at. So what the statement really reads is this. It says, give me the sum of this column. And then we have this as statement that we haven't even talked about yet that is really creating a new column from scratch with the results of the column that we're pulling it from. So let me run it and you'll see what I mean. Now you notice how this one's taking a little bit longer? You notice that it's still executing down here? I'm hoping the machine's locked up. I would kind of think it would be done by now. But the wheel is spinning. So far, you notice down here too. Oh, okay, so it's not finding stored procedure order total. All right, you know what? What's that?
It's highlighted on the
Yeah. All right, let's try one more time. It's always the little details that get you all right. I was like, all right, it shouldn't take that long. Right? Another thing that we could do is we could write a query here. So retail orders are table, right? Let's take a look at what's inside that table. Okay, well, there's not a lot in there. But let's say it was like thousands of rows of information. Now at least I can look at the order total, and I can go 445 plus 310 plus 480 is, I don't know, 1,000 something, right? Somewhere in that range. And so then when I look at the results of this, yeah, that's right. And then notice the as order sum is really only saying that my output column is going to be named that. So really I'm creating another data structure with the output, creating another table with the output. Very useful. Okay. This is a cool one too. Very useful statement in my opinion, because now we're going to do a count of what? Everything. From what? From the order item table. So let's run that. So we're counting how many order items we have. Once again, I can look at this. I guess I could do it like this, right? So I could do. Is that a table name or is that a database name? And your answer is? What is that name? Is that a table name? Yeah, from which table? And the reason I do this, of course, is to see, is 7 correct? 7 is correct. So I'm just verifying that information. Now for me, I thought it was kind of interesting that you could do some of these things almost in combination. So this is kind of our first example of that, where we are going to count the number of distinct department entries and then output it as a department column. So normally when we go to that table and we look at the department entries, I forget what stuff goes in there, but basically the department listing can be multiple, so there can be many of them listed, but I'm trying to find the number of distinct department entries and then output it as a department column. So that way it tells me how many distinct departments do I have? 3. It doesn't list them, but however it does tell me the total because that's what I asked. Take it to the next example here. All right, let's talk about this. It says, should be aware of 2 limitations to SQL built-in functions. All right, and these are important to note. You cannot combine table column names with a built-in SQL function. So if I'm going to do if I'm trying to output a whole bunch of columns, it does not want me to give me the department column and then let's go ahead and run the function and count it. It doesn't work because it sees it as really 2 distinct things. When I'm starting to list columns, it wants me just to stick with listing columns. It doesn't want me to combine. So when you're doing some of those higher end functions, you got to separate them out a little bit. So that's the first aspect of it. And then step number 2, you can't use table names in a SQL where clause because the SQL where clause operates on rows. So I cannot filter based on the table name. Does that make sense? Okay, that's not really that hard. So the where clause only works on rows. So as it says, choosing which rows will be displayed, whereas the aggregate functions operate on columns. So that's why, in these previous examples, like this one, those functions are listed up here. You're never going to see them listed in the other one. All right. Now, of course, these are queries that you could try to run, and then you'll get these outputs, and then when you see these error message, and the reason you're using this word like aggregate is so that when you see the error message that says aggregate, you understand what it means. It's linking it to a different construct. All right, next slide here. And this says performing calculations. And take a look at how they're structuring this. Take it over to SQL Server here. And it says select order number, SKU, and that, this is just perplexing me because this seems like it's contrary to what we just read, right? Well, really what it's doing is it's demonstrating the fact that this is not actually a built-in function. It can do math in this position. It can't call in one of these other, like the count function, and then list it with columns. But it can do math. So quantity times price. So like if you guys are order takers somewhere and I buy like 1 can of soda for $1, the extended price is $1. If I buy 2 cans of soda for $1, the extended price is $2, right? That's what that means. So what they're doing here is they're doing the multiplication right on the fly here, and that will totally work. So you can run that one and see that it takes the price and whatever, and if we saw those other columns, and you could put quantity and price in there, and you could see that it's calculating it correctly. All right. In this case, we're taking and we're putting some math now, and I'm wondering if we have a typo there too. Where's the typo? Yeah, the quantity times price thing. Seems like it's missing an opening paren. All right, so here we're going to pick a couple of columns, order number and SKU from the order item table. We do our math, and then if the quantity times price does not equal the extended price, wait, now we have a logical issue here, if you guys think about this. When you're looking at an extended price, that is, by definition, a combination of those two items. Logically, this is flawed. The reason this wouldn't work and give you nothing is because that can't logically be true. All right, next slide. Let's take a look at this. This is kind of interesting right here. This actually is an example of using concatenation in a database. And another indicator of why we teach you programming first and then teach you databases, because when you learn concatenation in a programming language, it's kind of like a process. And here we just expect that you kind of get what concatenation is. But concatenation is what by definition, folks? Yeah, basically joining strings together to turn them into something. Not necessarily, but as with a lot of programming and math, sometimes you do the parentheses just to help keep it straight in your head. However, in this case, why are the parentheses here? Or the quote marks, why are they here? Is that really what it's, Vaughn, is that really what it's saying? And then my second question is this syntax actually correct? Is right. All right, so this is the concatenation function, but typically when we add the plus mark, so just take a look at the output screen below. I'm not even going to run this, honestly, but we're selecting the SKU description, and then we're concatenating, seemingly, the buyer to the department, provided the buyer is in the department. So if you look at the, we're outputting that as a column called sponsor. So the question is, which is the text that's being inserted? And the answer is, this is the reason you see the quotes, and you know what your brain is telling you as programmers. I know what your brain is telling you because my brain thinks the same. Is, shouldn't there be a single quote here and a single quote here, or or shouldn't there be a quote here and here and here and here? And the truth is, this is the snippet of text that we're inserting. Space in space is what we're dropping in. Buyer and department, and see what I would do if I was like formatting this is I would do it like this. And clearly, the reason the author didn't is because he was running out of room on his PowerPoint and the stuff was moving to the next line. You understand? So I would go buyer, that's the column, concatenated to space in space, concatenated to the department, and then it outputs like this. So I can take multiple columns, concatenate them together, and output them to a different column. Totally does that. Kind of fun. Another example. Concatenation once again. What? All right. Oh, gotcha. So they're just showing the syntax here for both Oracle and MySQL, just in case. But notice in the Oracle database system, you use two pipes to do concatenation. Total oddball, by the way. And then in MySQL, you do it this way. So you actually, because in MySQL it's a function where you're passing parameters. So you're really passing this column. Here's the other thing you're joining it to. And that's kind of like the concatenation we do in Python, sort of, if you guys remember that. So that's kind of an oddity. Don't worry about those, not on the test. Some more terminology here. What do you suppose rtrim is? Because that's a function. Okay. The front?
And the beginning. Sorry.
Yeah. Okay. All right. So we're going to take the SKU description, and then we're going to concatenate the trimmed buyer name and the trimmed department together with the in string in space in space. And that way we don't have that like really spread apart column like we had before, and it's nicely trimmed down. So really what it's doing, that command, I forget what rtrim stands for, but it's kind of like the same thing, like my Java 2 people, whoever's in that class, we're not quite there yet. In the next week or so we're doing this, where you pull information from a form, and how do you know that the person's not typing in a leading or a trailing space on a form? It's a common input thing. And the other thing that like breaks it a lot these days is, I think of like when I log into my credit union account on my phone, I start typing my username, it'll auto type, and the auto type on a phone automatically adds a space to the end. Yeah. Right? Because you think you type your text message, right? And then you like type part of a word and you select the word, it drops it in, it adds a space at the end ready for the next word, so you don't have to type it. So, it's one of those things. So like good programmers always, think about those things. Now this is actually doing it within a database construct, but it's interesting, but it allows you to do a little bit of formatting and clean it up is kind of the point.
So that would be right trim, come to it at the end, and that trim would be that trim.
I assume so, but I think that R, they we'll have to look it up, but that R's got different meaning. But generally speaking, it sanitizes it, is really the way I look at it. All right. Now, they bring up this thing here, and the reason they're doing this is they want to talk about how you group things inside of a database. And sometimes, the data goes in a raw fashion, okay? So I might, like the information that we're seeing on the screen right now was not necessarily entered in that order, but when I run a query and output it, it might gather it in that order. order depending on what our criteria is. In this case, what they're trying to show us is that, you know, they're grouping here, I'm assuming by department, right? Because water sports together, camping are together, and climbing are all together. And often those groups can be used to do other things. So when you actually identify what something is grouped into, then you can kind of like sub-filter and do other things to that on a secondary level. All right, did I skip a slide there? Okay, there we go, we're good. So the interesting thing is you can actually use that command as an add-on to the select from where. So I can group things by department. So what this command does is in essence what we just saw here. So I can go from, you know, the data being output, and then I can clearly see as a human being just really quickly with my eyes that these are all alike, these are all alike, and these are all alike. And what the group by clause basically does is it takes it and pushes it. You see I can't select that slide, isn't that weird? There we go. It basically does that. So it not only recognizes that, but it boils it down for us. Now this is a little bit more of a complicated query than what you're seeing, but it shows you that we are counting the number of SKUs, outputting it as a column called number of catalog items, and then listing the departments, but we're grouping by department. So it basically is getting rid of all the superfluous entries. It's counting all the ones with that category and then giving us a nice little concise output. This takes a little bit when you start composing stuff like this and you work on the homework. This is the kind of stuff you should start thinking about. This is a good example, I think, as a base level one, because it shows you the thinking and the methodology behind it. So remember, select, so we're going to just look at this column, and then we're creating another column called this, based on the count. From this table, we're looking for certain things. So if it's a catalog item or whatever, you know, put it in, and then group them by department and just show them the count. I think it's fascinating, the logic that goes with that. All right. Now, in this case, they're taking that group by thing, and they're ramping it up. So they're having another clause here. So really, in this chapter, we're going from select from where, and we're adding a couple of higher level things. We're just grazing upon them right now. But not only are we grouping by department and doing that same count, but now we're also having an additional criteria to those groups where the count SKU, this item that we're also looking at up here, is greater than 2. So if that department has more than 4 catalog or 2 catalog items, let's see just that department. And so this is how database administrators think, which I think is fascinating, you know. And it takes a little bit of a leap because when we start doing some of the logic steps, they end up being a little bit different than how we do them in programming. So as a programmer, that transition's a little weird, but once you get the hang of it, not really a big problem. Right? They have this slide as well, where they start talking about how we, logic through this. And okay, so it says the SQL where clause specifies which rows will be used to determine the groups, and we figured that out already. Having specifies which groups will be used in the final result. So the having clause must go with the group clause. That's what that's saying. You guys see that? Okay. So I see this as a pretty important thing. And it says in general, place where before group by. Now it doesn't say you must. Did you catch that part too? This isn't a rule, it's a recommendation. So some products do not require that placement, but to be safe, so the convention is, put it before group. So if you look at this slide and how it's structured, these two, as a good practice, should always be after the where. But it also implies that, this kind of doesn't matter. but it is considered better syntax. Oh, I forgot the last statement, right? Right, I love statements like this. There's an ambiguity in statements that include both where and having clauses. The results can vary, so eliminate the ambiguity always. So SQL always applies where before having, even if you don't specify it that way. Get it? So it's better to, may as well just do it the way SQL reads it, you know, because SQL's changing it anyhow in the back end is what it's telling you. Almost done, folks. Oh, yeah. So if you want to group by more than one column, you can do that. So it is possible to actually list multiple group bys. And once again, I'm not demonstrating. And then if you are interested in this, where it says column names that must appear in group by, notice that there's a little kind of conflict of logic here once again, and that's why we have an error statement at the bottom. Don't bend your brains too hard on this one, but here's what it's trying to tell you, and what the author is trying to do is show you where you might fall into a logical flaw when you're working on a raw query and creating your own, and you see the message and you're like, okay, what is column skew data skew description is invalid in the select list because it does not contain either an aggregate blah 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 blah. Okay, so if you think about this, a department and the SKU, we're just displaying those. Then we're counting the SKUs, and then we're outputting it to a column. But now you want me to go ahead and group by department, but that's not going to make sense because it's not possible to do that given the fact that we're throwing in this thing. So in other words, you must, so column names that must appear in group by this must. This can't happen. I'm not really sure how to, I'm not explaining it well, am I? But maybe you want to read it from the book more than listen to me talk about it. They're just saying that you can't put that in there because if you start doing this, it's going to conflict with the fact that you have the department in the first